Hello, everybody. It's me again, Rich Andre, and today we're going to be talking about the Bernoulli's equation or Bernoulli's equations as it relates to differential equations. Okay, so we're just going to focus on the differential equations. We're not going to focus much on the physics part of the Bernoulli's equation, but we're just going to solve about one problem, one Bernoulli's equation related problem. Okay, so one thing that we have to realize, or one thing we have to keep in mind, is these three general formulas. The first one is, okay, the first one is you have to sort of know the standard form of Bernoulli's equation. So you would have something like this. Okay, so y prime plus p of x times y equals q of x times y to some sort of power. Okay, so it will look something like this. So this is the standard form of the Bernoulli's equation. By the way, I'm only using this example, okay? I extracted this example from the organic chemistry tutor, so credits to him for this. Thank you very much, sir. So this is the standard form for the Bernoulli's equation problems, okay? So the second thing that we have to keep in mind is once we have the Bernoulli's problem, okay, once we have the problem, we then have to get the integrating factor of it, okay? So it looks like something like this. We have to get the integrating factor and then use this general formula after we've got every single variable that we need in order to solve the problem, in order to get the answer, okay? So these formulas may look different from time to time, depending on what source you have, but the source that I got this from is the organic chemistry tutor. So thank you again, the organic chemistry tutor, for sponsoring this video. So either way, it's enough about that. Let's get to solving. Okay, so now that we've already got a standard form of the Bernoulli's equation, we've already got this problem, we need to get the integrating factor. How do we get the integrating factor? We just use this formula right here. Okay, so we need to list down what we've got already. What is the given? So we know that the p of x, here is a p of x. P of x is equal to 2 over x. How about q of x? Okay, q of x is equal to, well, x squared here. How about n? Well, we know that the exponent of y is 3, okay, so cube. So n equals 3. Okay, so those are the three things that we need to get from the problem. Now we need to get the integrating factor. You just substitute the variables right here. So we have I of x. Let's rewrite the formula, okay. So this is the integration sign, okay? So we have p of x dx. So now we have to substitute the variables. So e, 1 minus, what is the end? Is 3. P of x is 2 over x. And then copy, paste dx. Now what we need to do here is we just need to subtract. So e, negative 2, 1 minus 3 is negative 2. And then, okay, now that we have 2 over x, we just have to distribute negative 2. Okay, so negative 2 times negative 2. It's going to be negative 4. And then we're going to put negative 4 outside of the integral sign, just for the order, just for orderliness' sake. So we have 2 of x here. Okay? No, actually, sorry about that. This is actually 1. So we have 1 of x. So we have 1 of x here. Now what we need to do, okay? We need to get the integral of 1 over x. So what is the integral of 1 over x? Well, we know that the integral of 1 over x is equal to ln x. And that will turn into negative 4 ln x. Okay? So that's going to be our integrating factor. So now that we have that, okay, we have to put the negative 4 to the exponent of x. So x is equal to negative 4. Okay? And this is going to be our integrating factor. But we can also convert that to fraction forms. We have something like this. 1 over x to the power 4. Okay? Now that we've got the integrating factor, we need to get the general formula in order to solve this. So we can just copy and paste this. Sorry about that. Uh-huh. Okay. Now we can just solve and substitute the variables. So we have 1 minus 2, 3. So equals 1 over I of x. What is I of x? That is going to be equal to 1 over x to the power 4. And then I have a close bracket here, the integral 1 minus 3. And then q of x, what is q of x? That is x squared times I of x, which is 1 over x4, x to the power 4, dx plus c. Okay? So we first have to concern ourselves with these two. Let's just forget about everything else for now. 1 over x4 times x squared. Okay? So x squared, x2 minus the 2 exponents here, they're going to be subtracted. So we have x minus 2. Okay? Simple enough. It can also be, okay, it can also be 1 over x2. But we're just going to use x to the power negative 2 in order for us to use the power rule in integration. So we have this. 1 minus 3 is negative 2. Now, okay, Now we have to times 2. Okay, we have to distribute negative 2 to x to the power of negative 2. So that's going to be negative 2x minus 2. Okay. And then we get the integral. Okay. 2 plus 1. Oh, actually, let me redo that. You get the integral first of x minus 2. So that's going to be x minus 1 minus 1. Okay? Then you distribute negative 2 here. So negative 2 divided by negative 1 is going to be positive 2. Then we just copy 2x minus 1 gx plus c. You can get rid of the dx because it's already been integrated. So now we can focus on the other the left hand side of the equation and distribute. Okay. So in order to simplify this, okay, it's a complex fraction. You just have to divide 1 over 1. Then we're going to be left with x to the power 4. Both 1's will be cancelled. We're going to have x4. Okay. So now, you just have to substitute. Yeah, I mean distribute. So x, okay, x distribute to 2x negative 1, which is going to be 2x 3. If you distribute it to c, the answer is going to be cx 4. Okay. And then we have y minus 2. Okay. Y minus 2. As much as possible, we don't want to have a negative exponent on y. So we need to get the fractional form, which is 1 over y squared equals 2x3 plus cx power 4. Also, a little correction in this part. You need to convert it to 2 over x first. But whatever suits your fancy. Okay? They're both the same. So this is going to be final answer for the problem. Okay? So I hope you guys learned something from this. Thank you guys for watching. And this is Bernoulli's equation. I'm sorry if I didn't really solve any more problems here. But hopefully in the future I can or will be able to. Okay? So thank you guys for watching, and I'll see you guys in another video. This is me, Rich Andre. By the way, thank you very much for the organic chemistry tutor. He's also the one who taught me how to do this Bernoulli's equation, how to solve these Bernoulli's equations. So thank you very much for that. Okay? Credits to him. Thank you.